Hi, this is Samriddhi from Group 17. Our System Practicum mini project is to create a collaborative text editing platform where multiple users can work and edit on documents concurrently. Consider it just like Google Docs where people can edit and collaborate over the files. The main feature this should have is to continuously execute the changes made by one person over all the machines. The changes done at one system should be shown to other collaborators at the same time. Also, the files should be stored on a server so that they can be easily downloaded whenever required. To execute this, we propose to use a server client model for our text editors. In simple terms, a server client model is an architectural model where a number of systems are connected to a server through some network. The server can be given any function that we need, like in our case that would be update of document whenever some change arrives. So what really happens is the clients will send some requests to the server through the network, and then the server will respond by sending some response code. Also, we would be using TCP protocol model for our system. Why would we would be using TCP is first that it is more reliable than UDP or other protocols. Second, we need to preserve the order of changes made. So we need to preserve the order in which the changes are sent across the sockets. Uh, uh, as shown in this figure, the TCP server, when we bind the TCP server on socket, it will try to accept and listen to any of the call from a client, whereas a client will uh, send a connect request to the server, and as soon as the server accepts that request, the client can readily send its write command to perform whatever function that is required. So the real question comes is how we would be using this model in our text editing platform. So what we propose is that we would be using a text editor as a server. What that server will do, it will take care of all the changes that are made on different lines. For example, if one of my client changes some part, that change is readily sent to the server, which will then send or say broadcast those changes to all the client pool. In this way, my change done at one client will be shared among all the clients. So the main challenge here comes like how we would be addressing the conflicts that may appear when people are working concurrently. To cure that, we would be using a technique called operational transformation. So what operational transformation really means and what it does is like it is a basic technology that we would be using, that is mostly used in case of collaboration functionalities. Like shown here, if there's some change made over site 1 and there's some different change made over site 2, what operational transformation is says that whatever change you make at the site 1, send a copy of it to site 2, and correspondingly the change made at site 2 should be sent to the change made at site 1. Then what happens is both the sites will correspondingly try to change that operation in such a way that the final result is stored. I'll explain this with an example that so that it would be more clear. Like what happens is, consider this as a client and one is a server. Both of them are editing a string, say ABCD. So here what my client does is it wants to insert a say X after C. So it will be giving a command insert of X after 3, like after 3 units it is inserting X. So at the end it will get a string ABCXD. In the other case, when there is a server, let us say server performs a delete function and it tries to delete this P. So it will send the command that after first A, delete B. So the copy that it would generate will be ACD. So what we with operational transformation, what we say is send that change made at one place to the other. So here the delete command is sent to the client. So when this delete b comma 1 is sent to the client, so what that means is after 1 delete b, so the client will change its copy to ACXD. That is ideally what should happen. But if you consider what the client will send, what operation the client will send, so it would be basically insert x after 3. So the server will, if the server uses that command directly, it will come up with ACDX, which is complete mismatch. So so the thing is that we require some kind of pre-refinement in those operations such that both the copies should be same. This the solution is given by operational transformation. What it says that whatever operation you receive from a client or server, change it according to the previous previous operations done by that person or that system. For example, like here the server received the insert x comma 3 command, so it will try to change this command based on the previous commands that are executed by the server alone. So now the server will execute through operational transformation the command insert x comma 2. Basically it is changing, or say it is shifting its operation according to the delete command that was implemented by it before. So when it executes insert x comma 2, we get the result ACXD. Similarly, when the server will send delete b comma 1 to the client, so here the operation won't change because the previous command that was executed by client changed the part of the string afterwards. So the command will remain the same, and hence we get the same string that we require, which are identically copies of each other. So now the question arises, how we would be checking what change is made, where it is made, and how that would be transmitted. So for this we would be using a Google library which is named as diff match patch. So this library is available in C, CPP, Java, JavaScript, in many languages. So what it does is, the first step comes is diff. So if I'm given two blocks of plain data, it will simply compare both of them and result and give me the list of changes or differences that it encounters. What match does is, like, now I know the list of difference, it will tend to match a block of data wherever and wherever it is, it finds wherever the change is there, it will just highlight it and tell me that yeah, here there is change that you need to change it, and it will give me the exact position, the amount that needs to be changed. And at the end, what patch does is, it will basically merge the changes. For example, like I'm sending like a particular insert command into a big line. So my patch command will simply insert that line and complete the new string for me. So here this figure shows like the both see this client text and server text. Both of them will be maintaining a common file. So they would be comparing, and they will generate the differences by comparing their text with the common file. Once some difference is generated, that will go through match, and then it will be patched or merged with the other one. For example, here if we see some difference in client, it will go through 1A through difference, then 2 to edit, and then through 4a it will be patched to server text. And the other way around comes, like if we see some change in server, it will be identified by diff command and then matched and then patched with the client text. Here this is a simple example of what diff library will do. Like for example, one text I have, I am very fond of ice cream, and the other text that I have is I am very fond of candy. So after executing the diff command, I will have this: I am very fond of ice cream, candy. So this has detected that the first string has ice cream, which is not there in the second one. So it basically gives me a particular where the difference arises. So at the end, how we would be planning to implement this all these things is, it would be a complete HTML based front end, and we would be using JavaScript. We would, for the server client model, we would be using Node.js Express. Node Express is basically a light web-based platform based on Node.js, and it readily provides me WebSocket platforms. Along this, we would be using the operational transformation and Google diff patch match library implemented in JavaScript. Additional features, like if the time allows, would be like, if a person is making change, like if two or more people are collaborating, so whenever one person is made, so that change made by one person is highlighted by some different colors, so we can easily identify which person has done what change. The other feature that we can add is a comment utility or a chat area where we can even discuss whatever changes that we need to do. Okay, thank you for listening.